In this example, we have a multi-step problem. So the important thing is to identify the information that we've been given. So we're told a married couple, Greg and Jan, have been playing Powerball for 15 years and recently won the jackpot of $2.6 million. So we have the $2.6 million. They brought a dream house for $900,000 and are considering to giving their 5 sons a gift of $300,000. That is $300,000 each. They want to invest the remainder in a perpetuity. Now remember, if a perpetuity is used, then it has to go on and on forever. And we're told the perpetuity is at a rate of 5.4% per annum. So, what regular monthly payment would they receive? Okay, they have got 5.4%, but if they've spent a lot already, it's going to be 5.4% of what they have left. So, first thing we have to do is work out what they have left to invest if they were to spend the money in the way in which they thought they were going to do. So, the investment amount, that is the amount they have left over after they have bought the house and given their sons money. Now, 2.6 million, we won't write obviously as 2.6, but 2600,000 minus, they've purchased this house for $900,000, so we're going to have to subtract the $900,000 from it, and they're going to give each of their sons $300,000. So we're going to have to subtract another 5 lots of $300,000. When we work that out, we get $200,000. So they're left with a total of $200,000 left to invest. Now, this is going to be compounded monthly. So we know at this point V0 is 200,000, the amount they have to invest. We know the interest rate was 5.4% per annum, but they're going to get it compounded monthly, so we must divide that by 12, which brings us to 0.45% per month. So using our recurrence relation, D equals R on 100 times V0. We've just worked out our monthly interest rate is 0.45, so we've got 0.45 on 100 times V0, the amount they're going to start off with their investment, 200,000. That comes out to equal $900. So they would receive $900 per month. Part B says, Greg and Jan estimate they need $6,000 per month to live and travel comfortably. How much will they need to invest in a perpetuity to enable this monthly payment to continue indefinitely? So now we're going to work our problem backwards. We know D is equal to R on 100 times V0. What we also know is that R is equal to 0.45 on 100. We know what D is going to be. They want D to be $6,000. But that leaves us with V0. We know when it was $200,000, they would only get $900 per month. So using our calculator to rearrange this, what we would get is V0 would have to equal 1,300,000. So that is a significant difference between what they had between Part A and Part B. So Part C, what gift could they afford to give each of their 5 sons? So we're now in a very different situation here. We know to get $6,000 a month, they have to invest $1.3 million. So now let's look at their situation about what they can afford to give their 5 sons. So what we currently know is they have 2.6 million. They need to invest 1.3 million. And they need to spend $900,000 on a house. This leaves $400,000. They've said they've got 5 sons. $400,000 divided by 5 is $80,000 each.